The silence and the awakening. The night sky has always been the greatest liar in human history. When we look up, we see peace. We see a blanket of black velvet pinned with steady, unmoving diamonds. It looks silent. It looks empty. It looks safe. It was October 2025. The autumn air was just beginning to turn crisp in the northern hemisphere, carrying the smell of dry leaves and approaching winter. In the cities, people went about their Tuesday evenings. They waited for buses, they cooked dinner, they scrolled through their phones and they complained about the traffic. The world was busy with its own noise. We were obsessed with our borders, our economies and our small human arguments. We had forgotten that we live on a small rock floating in a very crowded, very fast-moving shooting gallery. The silence of the universe broke not with a sound, but with a notification. It did not start as an explosion. There was no flash of light that blinded the eyes. It started as a vibration in a billion pockets at the same time. It was a digital ripple. The breaking news banners appeared on television screens in airports and living rooms. Usually these red banners meant something political, a natural disaster or a celebrity scandal. We were used to those. We knew how to process them, but this was different. The headline was simple, yet it froze the blood of everyone who understood what it meant. Unidentified interstellar object detected within lunar orbit. For a moment the world held its breath. The silence of the cosmos suddenly felt very heavy. It was the feeling you get when you are home alone sitting in a quiet room and you hear a floorboard creak right behind your head. You realize with a sudden shock that you are not alone. The object was not in a distant galaxy. It was not light years away, a ghost from the past. It was in our backyard. It was closer to us than Mars. It was closer to us than the sun. In cosmic terms, it was standing right on our front porch, and we had not heard it walking up the driveway until it was already there. The realization hit humanity in waves. First there was confusion. Was it an asteroid, a comet, a piece of space junk? Then came the denial. Surely the sensors were wrong, surely the math was off. But the math is never emotional. The math is cold hard and absolute. This is where the waiting began. The hours following the announcement were perhaps the most agonizing in modern history. We were not waiting for a speech from a president or a prime minister. We were waiting for data. We were waiting for the astronomers, the physicists and the mathematicians, the new high priests of our civilization to interpret the signs. The contrast between the earth and the sky became painful to witness. Down here on the surface there was chaos. Social media became a storm of panic and wild theories. People were shouting in capital letters. Stock markets in Tokyo and London wobbled and dipped. Religious groups gathered in city squares. The internet was a mess of noise, fear and desperate jokes. But up there in the observatories atop mountains in Chile and Hawaii, and in the silent control rooms of space agencies, there was only a terrifying order. The scientists were not looking at monsters. They were looking at numbers, and the numbers were beautiful, terrifyingly precise things. They were watching a trajectory that defied the natural chaotic tumble of a rock. They measured the speed 150,000 kilometers per hour relative to Earth. They measured the rotation, steady, rhythmic, calculated. They measured the albedo, or the reflection of light. It was too bright, too consistent to be a dirty ball of ice and dust. While the people on Earth argued about what it meant, the object simply existed. It did not care about our fear. It moved with the perfect frictionless grace of Newton's laws. It was a visitor that did not knock. I remember sitting on my balcony that night looking up at the moon. The news report said the object was currently passing just beyond the orbit of the moon, roughly 400,000 kilometers away. It was invisible to my naked eye, but I felt it. I felt the weight of it. For centuries, we humans have shouted into the void. We sent radio waves, we sent gold records on the Voyager probes, we aimed our telescopes at the darkest corners of the universe, asking the same question, is anyone out there? We expected the answer to be a whisper from far away. We expected a radio signal that would take 100 years to decode. We did not expect the answer to arrive physically, silently, and so quickly. The feeling was not just fear, it was a strange, deep humility. Suddenly our skyscrapers looked like toys. Our wars looked like children fighting in a sandbox. The economy, the internet, the politics, it all felt incredibly small. The data eventually began to trickle out to the public. It came in units and the measurements that usually bored the general population, but now everyone became a student of astrophysics. We learned that the object was cylindrical. We learned it was approximately 800 meters long. We learned that it was not tumbling, it was stable. The scientists called it an anomaly. That's a gentle scientific word for something that should not exist. In the chaotic mess of nature, straight lines and perfect cylinders are rare. Nature makes rough, round, broken shapes. Nature makes potatoes, not pencils. This object was a pencil. As the night of October passed into the morning, a strange calm settled over the world. It was the calm of the waiting room. We realized that we were no longer the masters of our domain. We were the indigenous people of an island watching a massive ship anchor in our bay, having no idea if the visitors brought gifts, disease, or weapons. The silence of the night sky was no longer empty. It was full, it was watching us back. The awakening had happened. We woke up from the dream that we were the center of the universe, or that we were safely isolated by the vast oceans of space. The ocean had been crossed. The stranger was here. And as the sun rose over a frightened and fascinated planet, the only thing we knew for certain was that the silence would never feel the same again. The most haunting phrase in the world of astronomy is not, "I don't know." It is without a doubt it was there the whole time. We tend to think of discovery as a sudden flash, a moment where a telescope swings toward a patch of darkness and reveals something brand new. But in the modern era, discovery is often an act of archaeology. We dig through digital graveyards. We sift through mountains of old data that have been sitting on servers gathering virtual dust looking for things we missed. This is exactly what happened with 3i Atlas. Before it became a headline, before it became a mystery, it was just a ghost in the archives. To understand how we missed it and how we eventually found it, you have to understand a lovely little machine called TESS. TESS stands for the Transiting Exoplanet Survey Satellite, but you can think of it as the most patient photographer in existence. Most telescopes are like snipers. They zoom in on a tiny specific target to get a high-resolution image. TESS is different. TESS is like a security camera with a wide-angle lens that covers a massive amount of the sky all at once. It divides the sky into sectors and stares at each sector for about 27 days straight. It is an unblinking eye. It never sleeps, it never blinks, and it never looks away. Its primary job is to look for planets outside our solar system. It does this by watching stars. If a star's brightness dips by a tiny fraction of a percent, it might mean a planet has passed in front of it. To do this, TESS takes a picture every few minutes, compiling a movie of the sky. It captures everything: exploding stars, variable stars, and occasionally wandering objects passing through our own solar system. When 3i Atlas was officially identified, astronomers immediately did what they always do: they went backward. They calculated the orbit of the object, traced its path back in time, and asked, has any telescope looked at this empty patch of space before? The answer was yes. TESS had been staring right at it in May of 2025. When the team pulled the data from the archives, the feeling in the room was a mix of excitement and eerie stillness. On the screen, amidst the static of background stars, there was a faint fuzzy pixel that shouldn't have been there. It wasn't bright enough to trigger the automated alert systems back in May. It was just a whisper of light. But once you knew where to look, it was undeniable. This is what we call a pre-discovery image. It is a photograph of a ghost. This brings us to a strange realization about how we study the universe. We are always looking at the past. This is usually a deep philosophical concept. When you look at a star that is 1,000 light years away, you are seeing it as it was 1,000 years ago. You are looking at history. But with 3i Atlas, the concept of time was more personal, more immediate. The light from that smudge on the TESS image had travelled for nearly an hour to reach the satellite's camera. Then the data sat on a hard drive on Earth for months, ignored and unseen. The object had been screaming into the void, signalling its presence, but we were too busy looking at other stars to notice. It is a humbling reminder that the universe does not wait for us to be ready. It happens whether we are watching or not. However, the true shock of the TESS data wasn't just that the object was there, it was how it looked. In the grainy images from May 2025, 3i Atlas was located at a distance of roughly 6 astronomical units from the Sun. To put that in perspective, 1 astronomical unit is the distance from the Earth to the Sun. So this object was 6 times further out than we are, placing it well beyond the orbit of Jupiter. Out there, space is incredibly cold. It is a deep freeze. Objects that far out are usually just frozen rocks or chunks of ice, silent and dead. They don't do anything until they get much closer to the heat of the Sun. When a comet gets close to the Sun, the ice warms up, turns into gas, and creates a beautiful tail. This is expected behaviour. But 3 Atlas was not behaving. Even at 6 astronomical units deep in the freezing dark, the TESS images showed that Atlas was active. It wasn't just a sharp point of light like a distant asteroid. It was fuzzy. It had a coma, a cloud of gas and dust surrounding its core. This was the detail that made the astronomers pause and stare at their monitors. This is the anomaly that turned a simple rock into a major scientific puzzle. You see, for a comet to be active that far away, it cannot be made of normal water ice. Water stays frozen as hard as granite at that distance. The sun is just a slightly bright star in the distance. It provides almost no warmth. For Atlas to be shedding gas and dust at 6 astronomical units, it had to be made of something else. It suggested the presence of super volatile substances like carbon monoxide or nitrogen ice that boil at extremely low temperatures. Or it suggested something stranger. It meant that the object had an internal energy source, or perhaps the surface was reacting to something other than sunlight. To see activity at that distance is like seeing a snowman start to melt in the middle of a freezing winter night. It defies your immediate intuition. It tells you that the standard rules of rock and ice might not fully apply here. The archival footage from tests transformed our understanding of the object's timeline. It proved that 3I Atlas was not waking up because it was getting close to Earth. It had been awake for a long time. It had been travelling through the darkness, venting gas and dust long before it entered the inner solar system. This realization shifted the narrative. We weren't dealing with a sleepy visitor that was just now reacting to our sun. We were dealing with a traveller that had arrived in a state of high energy. The test data was the smoking gun. It confirmed that whatever this object was, it was robust, it was volatile, and it was active in a region of space where everything else sleeps. As the researchers stared at those pixelated ghosts from May, the sense of wonder began to mix with a slight edge of apprehension. We had found the footprint of the intruder months after it had already stepped through the door. We were playing catch-up with a ghost trying to understand a story that had started long before we opened the book. The test data was a gift, but it was also a warning. 3I/Atlas was not a normal comet, and it was not following the script. To truly understand the mystery of Hale-Bopp, we must first leave the comfort of our warm blue planet and journey outward. We must enter a realm where the rules of daily life change, where the environment is so hostile and so alien that even the behaviour of atoms begins to shift. We are going to talk about the physics of the deep freeze. When astronomers saw comet Hale-Bopp flaring up and becoming active while it was still beyond the orbit of Jupiter, they were not just surprised, they were scientifically unsettled. To explain why we have to pause our series and look at what the universe is really like at that distance, we need to understand the concept of the dirty snowball. Dirty snowball and the freezing reality of the outer solar system. The nature of cold. What is cold? In our daily lives, cold is just a feeling. It is needing a jacket or seeing your breath in the winter air. But in physics, cold is not a thing itself, it is merely the absence of heat, and heat is motion. Everything in the universe is made of atoms and molecules that are constantly vibrating, jiggling and moving. When things are hot, those particles are moving fast. When things get cold, that motion slows down. If you go far enough away from the sun, out past the asteroid belt and beyond the giant planet Jupiter, that motion slows to a near standstill. In this region of space, the temperature drops to hundreds of degrees below zero. It is a deep, penetrating cold that turns gases into solids and turns water into rock. This is the environment where comets spend most of their lives. They are creatures of the dark, deep freeze. The dirty snowball. For a long time, humanity did not know what a comet actually was. Was it a burning cloud? Was it a spaceship? In the 20th century, an astronomer named Fred Whipple proposed a model that is still used today. He called the comet a dirty snowball. Imagine you go to a parking lot after a snowstorm. The snowplows have pushed everything into a pile. It is not pure white snow. It is a mixture of frozen ice, dirt, gravel, black dust from car tyres and dark grime. If you rolled that into a giant ball, you would have a decent model of a comet. A comet is a nucleus, a solid core made of various types of ices. I say ices in the plural because in space water is not the only thing that freezes. There is water ice, carbon dioxide ice, which we call dry ice, carbon monoxide ice and methane ice. These are mixed with dust, rock and organic compounds. When a comet is far from the sun, it is completely frozen. It is just a dark, silent mountain of dirty ice tumbling through the void. It has no tail, it has no glowing atmosphere. It is essentially dead. The magic of sublimation. So how does this dead rock turn into the spectacular light show we see in the sky? The answer lies in a process called sublimation. On Earth, we are used to 3 stages of matter: solid, liquid and gas. If you take an ice cube, it melts into liquid water. If you boil that pure, it turns into a sort of steam gas. But in the vacuum of space, the pressure is 0. Because there is no air pressure to hold liquid water together, ice skips the liquid stage entirely. When sunlight hits the surface of a comet, the ice transforms instantly from a solid rock directly into a gas. This is sublimation. As this gas shoots off the surface, it drags dust and particles with it. This creates a cloud around the nucleus called the coma, and eventually the solar wind pushes that cloud back to form the famous tail, the anomaly of distance. This brings us back to the problem with Hale-Bopp. Physics tells us exactly how much heat is required to sublime water. We know that water ice is very stable. It requires a decent amount of warmth to wake up, break its bonds, and turn into gas. Usually, comets do not start sublimating water until they get relatively close to the Sun, typically around the distance of Mars or Earth. That is the frost line for water, the point where the Sun is strong enough to melt the ice. However, Hale-Bopp was discovered when it was 7 astronomical units away. That is 7 times the distance from the Earth to the Sun. It was beyond Jupiter. At that distance, sunlight is 25 times weaker than it is here on Earth. It is incredibly dim. The temperature on the surface of a comet out there is roughly minus 200 degrees Celsius. At minus 200 degrees, water ice does not sublime. It does not evaporate. It acts exactly like granite or steel. It is effectively a hard, inert mineral. A comet made mostly of water should have been asleep. It should have been invisible. But Hale-Bopp was not asleep. It was already spewing out huge amounts of gas and dust. It was bright enough for amateurs to find it years before it arrived. The mystery of the ingredients. This anomaly forced astronomers to realize that Hale-Bopp was a giant, but it was also chemically complex. If water wasn't driving this activity, something else had to be. This suggests that the snow in this dirty snowball contained large amounts of supervolatiles. These are materials that remain gaseous even at very low temperatures. While water freezes, solid substances like carbon monoxide and nitrogen can still turn to gas even in the deep chill beyond Jupiter. The fact that Hale-Bopp was so active so far away meant it was rich in these exotic primal ices. It was an ancient object, a time capsule that had preserved the chemistry of the very early solar system billions of years ago before the planets fully formed. It was gassing off its outer layers long before a normal comet would wake up. A moment in the void. Let us conclude this chapter by trying to visualize this environment. I want you to close your eyes for a moment and imagine you are there floating in space next to the comet out past the orbit of Jupiter. First, you notice the silence. It is absolute. There is no wind, no hum of machinery, no sound of nature, just a heavy, suffocating silence. Then you feel the cold. Even in a sophisticated spacesuit, you can sense the entropy, the lack of energy. You are drifting in a vacuum that is only a few degrees above absolute zero. You look around. The stars are not twinkling. Because there is no atmosphere to blur them, they are hard, unblinking points of diamond light piercingly bright against a background of infinite black velvet. You turn your head to look for the sun. You're expecting the large, warm yellow disk we see from Earth, but you don't find it. Instead, you see a very bright star. It is smaller, about 1/5 the size it appears from Earth. It provides light, but it offers almost no warmth on your skin. It looks distant and indifferent. And there, floating in front of you, is the comet nucleus. It is a mountain 40 to 60 kilometers wide. It is darker than coal. It tumbles slowly, silently. But from its surface, jets of gas are erupting, silent geysers, shooting out into the blackness, catching the faint sunlight and glowing like a ghostly halo. This is the lonely frozen stage where our protagonist Hale-Bopp began its performance. It was alive in a place where everything else was dead, and it was rushing toward us at thousands of kilometers per hour, bringing secrets from the dawn of time. As the calendar turned to the final days of October, the story of Comet Ison shifted from a tale of quiet observation to one of dramatic action. For months, astronomers had been tracking a small point of light moving through the cold darkness. But as the comet crossed the invisible boundary known as the frost line, the point in the solar system where the sun's heat becomes strong enough to turn frozen water instantly into gas, everything changed. The sleeping giant was not just waking up, it was beginning to scream. This period marked the beginning of the fire hose phase. To understand this, you have to imagine the sheer scale of what was happening on the surface of the comet's nucleus. For billions of years, this object had been a frozen relic, a dirty snowball drifting in the absolute zero temperatures of deep space. Now it was hurtling toward a furnace. The heat from the sun began to penetrate the outer crust of the comet. This was not a gentle melting process like an ice cube on a kitchen counter. In the vacuum of space, ice does not melt into liquid water, it sublimates. This means it transforms explosively from a solid block directly into a gas. As the comet raced closer to its encounter with the sun, this process accelerated at a terrifying rate. Scientists watching the data were astounded by the numbers. The comet was no longer just puffing out little clouds of steam. It was venting. The pressure inside the nucleus built up until it found weak spots in the surface rock. When it broke through, it created massive jets of vapor. This is where the fire hose comparison comes from. Imagine a high-pressure fire hose, the kind used to fight massive city fires, but on a scale that is hard to comprehend. Now imagine thousands of these hoses, turning on all at once, blasting material out into the silence of space. The primary material shooting out of these jets was water. However, in this environment, we do not see it as liquid drops, but as water vapor. The data received by telescopes showed a massive spike in the production of this vapor. It was estimated that the comet was losing millions of tons of weight every single day. It was bleeding its life force out into the solar system. This was the fuel that created the comet's glowing atmosphere, or coma, making it brighter and larger in the night sky. But water was not the only secret the comet was revealing. As the heat intensified, it dug deeper into the comet's core, reaching materials that had been frozen since the very birth of our solar system. Suddenly, the sensors detected a sharp rise in something else, hydrogen cyanide. While hydrogen cyanide is known on Earth as a dangerous and deadly poison, for astronomers spotting it in a comet is like finding gold. This chemical is a primal ingredient. It is one of the original building blocks that existed in the great cloud of gas and dust that eventually formed the Sun and the planets. Because hydrogen cyanide freezes at a very low temperature, seeing it boil off meant that the heat was finally cracking open the deepest, most pristine layers of the comet. It confirmed that Ison was a fresh comet, a visitor that had never experienced the heat of the Sun before. It was spilling its ancient secrets for the first time in history. As these gases blasted outward, they changed the shape of the comet itself. Through a telescope, a comet usually looks like a fuzzy round ball of light, but in late October, observers noticed something strange. The head of the comet, the coma, was losing its perfect round shape. It was becoming asymmetrical. This uneven shape told a violent story. It suggested that the jets on the surface were not firing evenly. Perhaps one side of the comet was softer than the other, or perhaps the rotation of the comet was exposing different faces to the Sun at different times. The pressure from the sunlight was pushing the gas and dust back, flattening the side facing the Sun and stretching out the side facing away. It looked less like a ball and more like a bullet or a teardrop struggling against a powerful wind. This asymmetry was a warning sign. It hinted that the structural integrity of the nucleus was under immense stress. The comet was not just melting, it was being pulled apart. Despite the violence of the physics involved, the visual result was a thing of haunting beauty. To the human eye looking through a telescope or in the long exposure photographs taken during this time, the violence was masked by a serene glow. The comet appeared as a ghostly emerald green apparition trailing a long, delicate veil of white dust. The green colour came from the gases glowing as they were energized by the ultraviolet light from the Sun. The white tail was made of tiny dust particles released from the ice as it evaporated, reflecting the sunlight like diamond dust. It was a magnificent paradox. We were watching a catastrophic event, a mountain-sized object being destroyed by the Sun, but from our vantage point it looked like a silent, graceful brushstroke across the stars. This was the beauty of a dying world. Every bit of brightness we saw was the result of the comet losing a piece of itself. The brighter it got, the faster it was dying. The fire hose was not just a display of power, it was a display of sacrifice. The comet was shedding its mass to create its spectacular tail, consuming itself to put on the greatest show on Earth. As October came to a close, the intensity only grew. The comet was moving faster now, caught firmly in the Sun's gravitational grip. The amount of water and dust being ejected continued to climb breaking records and defying the conservative predictions of experts. The fire hose was fully open, and the comet was charging headfirst toward its point of closest approach, perihelion. The stage was set for the ultimate test of survival, where the beauty of the coma would meet the brutality of the solar inferno. To look at the night sky is to look at a mystery wrapped in silence. For thousands of years, humans stood on the cool grass of Earth, looked up at the twinkling lights and wondered what they were. We could see where the stars were, and we could see how bright they were, but we could not touch them. We could not take a spoon and sample a planet 100 light years away to see if it tasted like rock or ice or gas. For the longest time we thought the composition of the universe was a secret we were never meant to know. But then we discovered that light is not just a way to see, it is a language to be read. This is the story of the prism of truth and the golden eye we built to read the secrets of the stars. This method of reading light is called spectroscopy. It is a long and difficult word, but the idea behind it is as simple and beautiful as a rainbow after a storm. Imagine you are standing in a dark room and someone shines a flashlight at you. You see a white beam, but if you hold a glass prism in front of that beam, the white light breaks apart. It spreads out into a fan of colours: red, orange, yellow, green, blue, indigo and violet. This is the spectrum. Now imagine that before that light reaches your prism, it has to pass through a cloud of gas. This is exactly what happens in space. When a planet passes in front of its star, the starlight shines through the planet's atmosphere before it travels across the galaxy to reach our telescopes. Here is the magic: the gas in that atmosphere is not invisible to the light. Different chemical elements love to eat specific colours of light. For example, if there is sodium in that atmosphere, it will absorb a very specific shade of yellow. If there is hydrogen, it will absorb a specific shade of red. When the light finally reaches us and we spread it out through our prism, we do not see a perfect rainbow. We see a rainbow with missing pieces. There are dark gaps, little black lines where the light was absorbed. These gaps are not random, they are a barcode. Every single element in the periodic table, oxygen, nitrogen, iron, helium, has a unique pattern of gaps. It is a chemical fingerprint. No two elements are the same. By looking at which colours are missing from the starlight, scientists can read the atmosphere of a world they have never visited. They can tell you with absolute certainty, this planet has water clouds, or this planet smells like rotten eggs because of the sulfur. But reading these fingerprints is incredibly hard. The planets are dim and the stars are blindingly bright. It is like trying to see a firefly buzzing next to a stadium floodlight while standing in a different city. To solve this, humanity built the ultimate reader of light, the James Webb Space Telescope. The James Webb Space Telescope is the most complex observatory ever sent into the void. It is not just a bigger version of the Hubble telescope, it's a different kind of creature entirely. It sees the universe in infrared light. This is light that our eyes cannot see, but our skin feels as heat. Infrared light is special because it can cut through the cosmic dust clouds that hide newborn stars, and it carries the clearest fingerprints of the chemicals we are hunting for, specifically things like water, methane, and carbon dioxide. Floating 1,000,000 miles away from Earth, shielded from the heat of the sun by layers of silver material as thin as human hair, the telescope opened its golden honeycomb mirrors. It turned its gaze toward a distant exoplanet, a world circling another sun. The astronomers on Earth waited. They were looking for a signal. They were hunting for the fingerprint of carbon dioxide. Finding carbon dioxide is a very big deal. On Earth, this gas is intimately connected to the temperature of our planet and the life cycle of plants and animals. Finding it on a distant world tells us that the planet has a heavy atmosphere rich in heavy elements. It suggests a history of geological activity like volcanoes, or perhaps something even more complex. When the James Webb Space Telescope captured the light from this distant planet, it spread the light out into a spectrum. The scientists looked at the data, which appears as a line on a graph. Usually these lines are jagged and messy, full of noise or static. You have to squint to see the pattern, but this time the line was different. As the scientists analysed the light frequencies, they saw a distinct sharp rise in the data. It was a mountain peak rising out of flatland. The instrument measured the depth of the absorption with incredible precision. The signal-to-noise ratio, a way of measuring how clear a signal is compared to the background static, hit a value of 7.6. In the world of science, a ratio of 7.6 is not a guess. It is not a maybe, it is a shout, it is a certainty. The telescope had detected a massive, undeniable amount of carbon dioxide. It was the clearest detection of this gas ever made on a planet outside our solar system. The fingerprint was perfect. The light had travelled for hundreds of years, carrying the signature of that carbon molecule, just waiting for an eye sharp enough to read it. It felt like magic. We were looking at a graph on a computer screen, just a jagged line with a high peak, but that line represented a real place. That 7.6 ratio meant that on a world far beyond our reach there is an atmosphere. There is wind, there is the heavy blanket of carbon dioxide trapping heat. For a moment, the distance between Earth and the stars vanished. We were not just looking at a dot of light anymore. We were looking at the air of another world. The prism of truth had worked. It showed us that the chemistry of the universe is universal. The same carbon that sits in our lungs and builds the trees in our forests is floating out there in the dark, wrapping around a lonely planet, writing its signature in the starlight, waiting to be read. This discovery opened the door. If we can see carbon dioxide this clearly, what else can we see? Can we see the fingerprint of ozone? Can we see the fingerprint of industrial pollutants? Can we see the breath of a living biosphere? The light is there. The library of the universe is open. We finally have the glasses to read the books. To understand the secret recipe of Comet Borisov, we must leave our current time and place. We have to turn back the clock not just by a few years but by billions of years. We must travel across the galaxy to a place that no longer exists, the nursery where this comet was born. Imagine we are floating in space looking at a brand new star. It does not look like our sun does today. It is angry bright and surrounded by a massive swirling flat cloud of gas and dust. This is what astronomers call a protoplanetary disk. It looks like a giant glowing pizza made of cosmic material spinning around the young star in the center. This disk is the kitchen where planets, moons, and comets are cooked. It is a chaotic, messy, and violent place. Dust grains are smashing into each other, sticking together to form pebbles. Pebbles smash together to form boulders, and eventually these boulders become the cores of planets and comets. But here is the key to our mystery. The kitchen does not have the same temperature everywhere. This is the most important part of the first hypothesis regarding where Borisov formed. Think of the young star in the center as a bonfire on a cold night. If you stand right next to the fire, you feel intense heat. If you walk 10 steps back, it is warm. If you walk 100 steps back into the dark, it is freezing cold. This temperature difference creates invisible boundaries in the disk called ice lines. Closest to the star, it is too hot for anything to be solid except rock and metal. Any water here would instantly turn into steam, but as you move away from the star, you hit the first major boundary, the water snow line. This is the distance where it is finally cold enough for water vapor to freeze into solid ice. In our own solar system, this line is somewhere between Mars and Jupiter. This is why the inner planets like Earth differ so much from the outer gas giants. However, for Comet Borisov, we need to go much, much further out. We need to go past the water snow line into the deep freeze of the outer system. As we travel further away from the star, the temperature drops drastically. We pass the carbon dioxide ice line. Here, the gas we breathe out, carbon dioxide, stops being a gas and freezes into white dry ice. Comets born here contain a mix of water ice and carbon dioxide ice. But Borisov is special. The chemical analysis showed us that it is incredibly rich in a chemical called carbon monoxide. This is a very simple molecule, just one carbon atom and one oxygen atom, but it tells us exactly where to look. Carbon monoxide is extremely sensitive to heat. It is what scientists call super volatile. You can think of it as the shyest ice in the universe. Even a tiny amount of warmth will make it vanish and turn back into gas. For carbon monoxide to freeze into a solid ice and get trapped inside a comet, it must be unimaginably cold around minus 250 degrees Celsius. This tells us that Comet Borisov did not form near the water snow line. It formed in the darkest, coldest edges of its home system. We call this the carbon monoxide ice line. Let us visualize this formation. Billions of years ago in that alien system, trillions of miles away from the stardust mixed with carbon monoxide frost. It was a quiet, dark region. Because it was so cold, the carbon monoxide ice was stable. It acted like a glue mixing with water ice and dust to build the body of the comet. Borisov was built in a deep freezer. This brings us to the big question. Why is this different from the comets in our own solar system? In our solar system, many comets that we see, often like the Jupiter family comets, have lost a lot of their carbon monoxide. There are two reasons for this. First, many of them may have formed closer to the Sun, where it was too warm for carbon monoxide to survive in large amounts. They are made mostly of water ice and dust. Second, comets in our system have often been looping around the Sun for a long time. Every time they get close to the Sun, they heat up. Since carbon monoxide boils away so easily, it is the first thing to escape. After thousands of trips around the Sun, a comet becomes depleted. It is like a soda that has been left open for too long. All the fizz, the volatile gas is gone. Borisov is different because it is pristine. It has likely never been close to a star before. It formed in the deep freeze, was kicked out of its home system, and spent millions of years traveling through the absolute zero temperatures of deep space. It stayed in the freezer the whole time. When it finally entered our solar system and approached our Sun, it was the first time that heat had ever touched its surface. The fizz was still there. The massive amount of carbon monoxide gas that astronomers saw was the ancient ice formed billions of years ago in the dark outer rim of an alien system, finally waking up and turning into gas. So the first hypothesis tells us a story of location. It suggests that Borisov is not chemically strange or weird. It is only different because it was born in the suburbs. It was born so far away from its star that it captured ices that normally cannot survive closer to the heat. If we could look at the protoplanetary disk of Borisov's home, we would likely see a massive extended disk stretching far out into the dark. And somewhere in those cold outer rings, a small chunk of rock and ice came together, locking in a sample of carbon monoxide like a time capsule waiting to deliver its message to us billions of years later. This confirms that the chemistry of the universe is universal. The same cooking rules apply everywhere. If you have a star and you have a disk and you go far enough out where the temperature drops near absolute zero, you will cook up a comet exactly like Borisov. It is a standard recipe just prepared in a very cold kitchen. To understand the second major possibility regarding the nature of Oumuamua, we must leave behind the excitement of alien technology and enter a realm that is quieter, colder, and perhaps even more profound. We must leave the warmth of our sun and step into the absolute stillness of the void between the stars. This is the domain of the second hypothesis, the natural processing of an icy body by radiation over eons. This story begins with the concept of deep time. It is a difficult idea for the human mind to truly grasp. We measure our lives in hours, days, and years. We think a century is a long time. We think the history of human civilization spanning a few thousand years is ancient. But to the universe, these spans of time are less than the blink of an eye. In the context of the cosmos, human history is just a fleeting moment. The Traveller. Oumuamua operates on a different clock. Before it entered our solar system, before it was detected by our telescopes, it had been drifting. It did not drift for weeks or months. It tumbled through the dark, empty gaps between star systems for millions, perhaps hundreds of millions of years. This is deep time. It is a timescale so vast that mountains can rise and fall and oceans can dry up while the object simply continues its silent journey in the dark. In this profound isolation, the object was not entirely alone. Although interstellar space seems empty, it is filled with invisible energy. It is washed by a constant rain of high-energy particles known as cosmic rays. These are tiny fragments of atoms stripped of their electrons, moving at nearly the speed of light. They are shot out by dying stars, exploding supernovas, and the violent hearts of distant galaxies. For all those millions of years, Oumuamua was bombarded by these particles. It is a process we can think of as cosmic weathering. On Earth, wind and water shape our rocks. In deep space, radiation shapes them. Imagine the surface of the object when it was first born. It was likely a pristine frozen chunk of ice, rich in water, nitrogen, carbon monoxide, and methane. It was likely bright and reflective, but then it was ejected from its home system. It was thrown out into the cold night. As it drifted, the cosmic rays began their work. When these high-energy particles strike the surface of an icy body, they do not just bounce off. They crash into the frozen molecules. They break the chemical bonds that hold the ice together. It is a violent interaction on a microscopic level. The energy from the cosmic ray shatters the simple molecules of ice. Over time, these broken pieces reassemble. They form new, heavier and more complex chains. Simple carbon and hydrogen atoms are forced together to create heavy organic compounds. In the laboratory, scientists call this a process of irradiation. In the poetic language of the cosmos, we can call it a callous burning touch. This process changes the color of the object. The clear or white ice slowly darkens. It turns a deep, dusty red. This is the same red hue we see on some objects in our own solar system far away from the sun, where ancient surfaces have been exposed to space for a long time. It is a crust, a heavy organic mantle that builds up layer by layer, micrometer by micrometer over the epochs. This leads us to the core of the second hypothesis. The strange behavior of Oumuamua, the way it accelerated without a visible tail, might be explained by this crust. The theory suggests that Oumuamua was essentially a toasted snowball. The exterior was a shell of dried, hardened organic material baked by radiation. But inside this shell, deep within the core, the ancient ices remained frozen and preserved. The thick red crust acted as an insulator. It was a thermal blanket protecting the volatile heart of the object from the slight warmth of starlight as it drifted through the galaxy. However, when Oumuamua finally dived into our solar system, the heat became intense. It flew very close to our sun. The heat penetrated the red organic shell. It reached the frozen ice inside. The ice did not melt into liquid water. In the vacuum of space, it turned instantly into gas. This gas built up pressure under the shell. It sought a way out. It pushed through cracks and vents in the weathered surface. It jetted out into space, acting like a natural rocket engine. This pushed the object, giving it that mysterious extra speed that confused astronomers. The reason we did not see a tail, the glorious bright stream of dust and gas that usually follows comets, was because of that radiation-baked crust. The dust was trapped in the heavy, sticky organic material on the surface. Only the gas escaped, invisible to our telescopes. The time capsule had cracked open just enough to push the traveller forward, but not enough to reveal all its secrets. There is a deep melancholy to this image. Think of the stone tumbling through the endless night. It is completely silent. There is no air to carry sound. There is no light to cast a shadow, only the faint distant pinpricks of stars that offer no warmth. For eons it was a ghost moving through a graveyard. It passed through regions of space where stars were being born and regions where stars had died. It drifted while dinosaurs walked on Earth. It drifted while continents broke apart and drifted on our planet. It continued to tumble while humanity learned to make fire-built cities and finally looked up at the sky. In this light, Oumuamua is not just a rock, it is a record keeper. The damage on its surface, that red stain of radiation, is a physical memory of its journey. Every cosmic ray that hit it was a witness to an event somewhere in the universe. It carries the chemical signature of the place it was born, a star system we have never seen and perhaps never will. This hypothesis asks us to respect the power of nature over time. It does not require intelligent engineers or alien signals. It only requires the laws of physics and the vast, terrifying patience of the universe. It suggests that the void between stars is not just empty space, but a factory of sorts where simple ice is processed into complex organic matter, creating seeds that tend to drift from one star to another. We are looking at a traveller that has survived the harshest environment imaginable. It is a survivor of the dark. When we looked at that red dot moving away from us on our screens, we were looking at a visitor that had been lonely for longer than our species has existed. It was a brief encounter with eternity. The object warmed itself by our fire for a fleeting moment, stretched its legs with a burst of gas, and then returned to the dark, carrying its secrets back into the deep time from which it came. While the astronomers on Earth were left pacing in their observatories, frustrated by the blinding brilliance of our own star, a completely different story was unfolding millions of kilometers away. To understand this, we have to shift our perspective away from the comfortable blue skies of our home planet and transport our minds to the rusty, cold deserts of Mars. On Earth, the timing was simply bad luck. This implies a phenomenon known as solar conjunction. This happens when the sun moves directly between Earth and another planet, in this case Mars. Imagine trying to have a conversation with a friend standing across a field, but there is a massive roaring bonfire directly in the line of sight between you. You cannot see your friend because of the smoke and light, and you cannot hear them because the fire is too loud. For radio astronomers and spacecraft controllers, the sun acts exactly like that bonfire. It emits huge amounts of radio waves and charged particles. If we try to send a command to a rover or a satellite during this time, the sun's interference acts like static noise scrambling the message. If we try to listen, all we hear is the roar of the sun. During these periods, Earth is effectively blind and deaf to anything happening on the other side of the solar system. We are cut off. However, the universe does not stop moving just because humans cannot see it. The cosmic dance continues, and while Earth was blinded by the glare, Mars had the equivalent of a front row seat. Mars was positioned perfectly. Because of the geometry of the orbits at that moment, the red planet was not looking into the sun to see the approaching visitor. Instead, it had a clear, dark sky. If you were standing on the surface of Mars, looking up through its thin, butterscotch-coloured atmosphere, you would not have been squinting against the light. You would have seen the velvet darkness of space sprinkled with steady stars. But there were no humans standing there to watch. Instead, we had our mechanical envoys. This is where the true beauty of our modern technological age shines. We have surrounded Mars with a fleet of robotic-eyed sentinels that never sleep and never blink. Two of these sentinels, the ExoMars Trace Gas Orbiter and the Mars Express, played a crucial role during this time. These are spacecraft built by the European Space Agency designed to circle Mars and study its atmosphere and surface. But in this specific instance, they became our eyes when our own were useless. The coordination required to make this happen is nothing short of a mechanical ballet. These robots are millions of kilometers away. During solar conjunction, we cannot use a joystick to turn them around in real time. We cannot shout instructions telling them, "Look over there, something is coming." By the time our radio signal fought through the sun's interference, it would be too late or the signal would be too corrupted to be understood. Instead, the commands had to be uploaded as though did weeks in advance. The engineers on Earth had to predict the future. They had to calculate exactly where the strange interstellar visitor would be and at what precise second. They had to program the spacecraft to rotate to adjust their solar panels and to point their sensitive instruments at a seemingly empty patch of black space. And the robots performed perfectly. High above the Martian surface, in the silence of the vacuum, the Mars Express orbiter adjusted its orientation. It is an older machine, a veteran of space exploration, yet it remains one of our most reliable assets. Alongside it, the ExoMars Trace Gas Orbiter, a newer and more sophisticated machine, readied its camera systems. There is something deeply poetic about this scene. Down on Earth, the sun was dominating the sky, creating a wall of noise and light that blocked our view. But at Mars, there was only silence. The red planet is a quiet world. It has no oceans to roar, no thick forests to rustle in the wind, and no cities to hum with activity. In this stillness, the interstellar visitor arrived. It did not crash, it did not make a sound, it was a ghost passing in the night. To the human eye, it would have been just a faint point of light moving against the background stars. But to the sensors of the Mars orbiters, it was a treasure trove of data. They tracked its trajectory. They measured how the light reflected off its surface. They looked for heat signatures. While Earth was blinded, Mars watched the show. The orbiters recorded the event onto their hard drives. They stored the images and the spectral data, holding on to the secrets of the visitor. They waited patiently for the geometry of the solar system to change. They had to wait for Mars to move along its orbit, stepping out from behind the glare of the sun, so that the line of sight to Earth would be clear again. This contrast highlights the fragility of our position in the cosmos. We often think of Earth as the center of observation, the place from which all knowledge flows. But in this moment, Earth was the one in the dark. We were the ones with the handicap. It was the alien world, Mars, that held the truth. The visitor passed by Mars at a tremendous speed, thousands of kilometers per hour. It did not slow down. It was falling through our solar system, influenced by the gravity of the sun, but it was moving too fast to be captured. It was a traveler from the deep void between the stars, just passing through our neighborhood. When the conjunction finally ended and the interference from the sun faded away, the data began to flow. The radio dishes on Earth in places like Australia, Spain, and California turned their giant ears toward the red planet. The stream of ones and zeros bridged the vast gap of space. What the scientists saw when they decoded the data was a triumph of robotic cooperation. The images and measurements taken from the Martian vantage point filled in the gaps that we could not see from Earth. We saw the object from a different angle under different lighting conditions. It reminds us that in the exploration of the universe, we are not just biological beings stuck on a rock. We are a network of intelligence. We have extended our senses to other worlds. When our biological eyes are blinded by the sun, we have electronic eyes orbiting a neighbor planet that can see for us. The silence of Mars during that event stands in stark contrast to the noise of human curiosity. We shouted questions into the void, but the sun drowned us out. Mars, however, simply watched. It sat in its dusty stillness, offering the best seat in the house to watch the lonely traveler depart as quickly as it had arrived, heading back out into the infinite black ocean of interstellar space. It starts with a simple observation that defies common sense. When we look at this moon, we are looking at a body that is incredibly small in the grand scheme of the solar system. It is a tiny ball of ice and rock measuring roughly 500 kilometers across. By all the laws of planetary physics that we held dear for decades, a world this size should be dead. It should be a frozen, silent relic, a cold corpse floating in the dark. Small objects have a large surface area relative to their volume, meaning they lose their internal heat very quickly. Imagine a cup of coffee left out in a blizzard. It goes cold in minutes. Now imagine a planet the size of a large state left out in the deep freeze of space for billions of years. It should be solid ice all the way to the core, and yet it is roaring. This is the heart of the paradox. We are witnessing a level of activity that belongs to a much larger, more energetic world. The sheer violence of the plume's jets of water vapor and ice particles shooting hundreds of kilometers into space suggests an engine of immense power hidden beneath that calm white asymptote surface. When scientists first attempted to balance the energy budget, the numbers simply refused to match. It was like trying to power a high-speed train with a single AAA battery. The math, quite frankly, was broken. The primary suspect for the heat source is tidal heating. This occurs when the massive gravity of the parent planet stretches and squeezes the moon as it orbits you, creating friction deep inside. It is the same principle as bending a paperclip back and forth until the metal becomes hot to the touch. However, when astronomers calculated the amount of heat such friction could generate for a body of this small size, the result was far too low. The moon is radiating gigawatts, that is billions of watts of thermal power from the south polar region alone. This is 10 times more energy than the standard tidal models predicted. This discrepancy forces us to confront a humbling truth: the universe does not feel obligated to follow the models we build in our laboratories. We humans love linear patterns. We love it when input equals output. But nature often operates on chaos and complexity. This tiny moon reminds us that our understanding of planetary geology is still in its infancy. We had assumed that to be geologically active, a world needed to be the size of Earth or Mars, or at least have the violent volcanic surroundings of Jupiter's moon Io. We were wrong. So if standard tidal flexing is not enough, what is happening down there? One expanding hypothesis looks at the specific movement of the moon. It does not just orbit, it wobbles. This slight physical vibration known as libration implies that the icy crust is completely detached from the rocky core floating freely on a global ocean. If the crust can slide around independently, the friction generated is much higher than if it were stuck to the rock, but even that might not account for the sheer intensity of the heat. This leads us to the porous core theory. Imagine that the rocky core of this moon is not a solid dense ball of stone, but rather something resembling a hard sponge. If the core is porous, water from the subsurface ocean can seep deep into the rock. As the rock is squeezed by tidal forces, it grinds together, heating the water trapped inside its pores. This heated water then becomes buoyant and shoots upward, carrying heat from the deep interior out to the ice shell. It is a planetary-scale hydrothermal circulation system, similar to the radiator in the car, but moving heat from the center of the moon out to the vents. Then there is the mystery of the vents themselves. The active region is remarkably small. We are talking about fissures, the famous tiger stripes, where the hottest points are often confined to areas less than 1 kilometer wide. It is baffling to consider that the geological destiny of an entire moon is being dictated by these narrow scars. From these narrow channels, the water does not just leak out, it explodes. The environment implies the existence of nozzle-like structures. As the pressurized liquid water rises through the cracks, it hits the vacuum of space. The drop in pressure is instant. The water flashes into vapor and ice crystals, accelerating to supersonic speeds hundreds of meters per second. This is not a gentle steam, it is a jet engine made of ice. These vents act as safety valves for the pressure building up below, but they also serve as windows, because the material is coming from deep inside. Studying the exhaust of these vents tells us what is happening in the boiler room. We have detected salts, organic compounds, and silica particles. The silica is particularly telling. Tiny grains of nanosilica usually only form when rock touches water at temperatures of at least 90 degrees Celsius. This singular fact changes everything. It means that somewhere down in the crushing dark beneath kilometers of ice there is a place that is not just warm by the standards of space, but hot by the standards of a kitchen. It suggests active hydrothermal vents on the seafloor billowing dark mineral-rich water into the ocean. This brings us back to the paradox. We have a world that is too small to be hot, yet it is cooking. We have a crust that should be solid, yet it is cracking and sliding. We have a math equation that does not balance, and in the gap between our calculations and the reality lies the potential for life. The mystery of what lies beneath is no longer just about geology, it is about biology. On Earth, wherever we find hot water interacting with rock, we find life. We find microbes that eat chemicals rather than sunlight. The paradox of scale tells us that size is not the determining factor for a living world. You do not need a massive planet with a thick atmosphere to create a habitable zone. You just need a heat source, a liquid medium, and the right chemical ingredients. Nature has broken our rules to show us a new possibility that the most exciting environments in the solar system might not be on the giant planets, but hidden inside the tiny overlooked marbles rolling around them. The heat is internal, the ocean is capped, and the activity is intense. This moon is keeping its secrets well, burying them under layers of frozen armor, letting only enough escape to tease us, to force us to update our math, and to compel us to return. When Oumuamua tumbled past the sun and began its long journey back into the dark void, it left behind more than just a trail of confusion regarding its physics. It left a deep fracture in the way we look at the sky. For most astronomers, this object was a fascinating natural puzzle. But for others, the puzzle pieces did not fit unless one specific daring element was added to the picture-intelligent design. This is where the story of Oumuamua shifts from a tale of ice and rock to a debate about our place in the universe. The most prominent voice in this controversy was Loeb, a highly respected theoretical physicist from Harvard University. While the rest of the scientific community was busy calculating tumbling rates and thermal properties, Loeb looked at the data and asked a question that made many uncomfortable. What if it is not a rock at all? What if it is a machine? Loeb's argument was rooted in the object's strange behavior, specifically the extra push it received as it moved away from the sun. As we discussed previously, Oumuamua accelerated slightly, deviating from the path gravity alone would have dictated. To Loeb, the lack of a visible tail, the gas and dust that usually acts as a rocket thruster for comets, was a smoking gun. He proposed that if it was not outgassing, perhaps it was being pushed by sunlight itself. For sunlight to push an object that hard, the object would have to be incredibly thin and light, like a sail catching the wind. Since nature rarely makes large sheets of material less than a millimetre thick, Loeb suggested it could be a light sail, a piece of defunct technology from an advanced alien civilization drifting through the galaxy like a shipwreck in the ocean. This idea ignited the public imagination. It appeared on news channels and in newspapers around the world. It spoke to a deep primal hope that humans hold inside the hope that we are not alone. However, science is not built on hope. It is built on evidence and repetition. The reaction from the broader scientific community was swift and grounded in skepticism. They did not reject the idea because they hated aliens. They rejected it because of a principle called Occam's razor. This principle suggests that the simplest explanation, the one requiring the fewest leaps of faith, is usually the correct one. Astronomers argue that we do not need to invent an alien spaceship to explain Oumuamua. Later research provided a compelling natural explanation that did not require a visible tail. Scientists proposed that Oumuamua might have been an iceberg made of hydrogen or nitrogen. As the sun heated it, the gas would escape. Because hydrogen and nitrogen are transparent to our telescopes, we would not see the white dusty tail typical of water comets. The rocket engine was there. It was just invisible to our eyes. This theory explained the speed, the shape, and the silence of the object without needing a hypothetical civilization. To understand why scientists prefer the invisible rock theory over the alien spaceship theory, we have to look at how we understand the architecture of space. This brings us to the concept of the ecliptic plane. Imagine our solar system not as a messy cloud, but as a flat dinner plate. In the center of the plate is the Sun. The Earth, Mars, Jupiter, and the other planets all orbit on the flat surface of this plate. They move around the Sun in roughly the same level. This flat level is called the ecliptic plane. Almost everything born in our solar system stays on this plate. Asteroids and planets obey this traffic rule. However, Oumuamua broke the rule completely. It did not drive along the plate. It dove down from above. Imagine dropping a marble from the ceiling directly onto the dinner plate. It punches through the flat surface near the Sun, swings around, and then shoots back up toward the ceiling. Because it came from such a steep angle, nearly 90 degrees to the planets, we knew immediately that it was not from here. It was a visitor. This trajectory is important for statistics. When we talk about statistics in astronomy, we are talking about the likelihood of finding a needle in a haystack when the haystack is the size of the universe. Some people argued that it was too coincidental for an alien probe to fly past Earth, just as we had the technology to see it. But the counter-argument relies on the sheer number of objects in space. Think of it like a lottery. The chances of you winning the lottery today are almost zero, but the chances of someone winning the lottery are very high. If you buy millions of tickets, you will eventually win. Our telescopes are like buying lottery tickets. We are scanning the sky every single night, cataloguing millions of points of light. Eventually, simply by the laws of probability, we were bound to catch an interstellar object. The fact that we found Oumuamua does not mean it was sent to find us. It means we have finally looked at the sky long enough to see the traffic passing by. The debate over Oumuamua teaches us a vital lesson about critical thinking. The human brain is wired to look for patterns and agency. When we hear a rustle in the bushes, our ancestors survived by assuming it was a tiger, not the wind. We're evolved to detect others. When we see a rock moving strangely in the sky, our instinct is to ask who is driving it rather than what forces are pushing it. Avi Loeb's hypothesis was a valuable exercise because it forced scientists to double-check their math and refine their natural theories. It pushed the boundaries of what we consider possible. However, the eventual consensus points us toward a truth that is quieter but no less beautiful. There is a profound majesty in the natural explanation. If Oumuamua is a fragment of a shredded planet or a hydrogen iceberg ejected from a dying star system, think of the story it tells. It means that this silent red cigar-shaped stone travelled through the freezing emptiness of the galaxy for millions of years, perhaps billions of years. It drifted past dead stars and nebulae, moving in complete darkness, only to stumble into our solar system for a few brief months before leaving forever. We often feel that for the universe to be interesting, it must be populated with other beings like us. We want the drama of a first contact, but there is a different kind of wonder in realizing that the universe is physically dynamic and connected. We are being pelted by rocks from other stars. The galaxy is mixing its materials, trading dust and ice across light years. The search for extraterrestrial intelligence is a serious and noble scientific pursuit. We scan for radio signals and look for laser flashes because the discovery would change history, but we must be careful not to let our desire for that discovery cloud our vision of reality. Oumuamua was likely not a message in a bottle. It was the bottle itself washed up on our shores by the cosmic tide. Accepting Oumuamua as a natural object does not make it boring. It makes it a messenger of the physical reality of the Milky Way. It tells us that planetary systems eject their building blocks, that the space between stars is not empty, and that if we are patient in it, the universe will bring its secrets to our doorstep. We do not need to project our own faces onto the stars to find them beautiful. The silence of the stone tumbling in the dark is a story grand enough on its own. In the grand library of the universe, most shapes are stories of return. The circle and the ellipse are the shapes of loyalty. The Earth returns to its spring every year. The moon returns to the full phase every month. These are closed loops, comfortable geometries that promise us that what is lost will be found again, and that goodbye is only a temporary pause before the next hello. But there is another shape, a frightening and beautiful shape known as the hyperbola. This is the geometry of departure. It is the mathematical proof that some things once gone are gone forever. To understand the hyperbola, we must first understand the concept of escape. Gravity is like a deep well. The sun sits at the bottom of this well, pulling everything toward it. To live in the solar system means you are trapped in this well, circling around and around on the walls, moving fast enough not to fall in, but not fast enough to climb out. This is what it means to be a planet. We are prisoners of our own star, held in a warm and comfortable captivity. However, if an object moves fast enough, it can break these chains. There is a specific speed limit, a magic number written into the fabric of space. If you travel slower than this speed, you travel in an ellipse. You are bound to return. But if you travel faster than this speed, you achieve what is called escape velocity. At this speed, the kinetic energy, the energy of motion, is greater than the gravitational potential energy trying to hold you back. The invisible rope snaps. The curve of your path stops bending back upon itself. Instead, it opens up. The ends of the path flare outward, getting straighter and straighter, pointing toward infinity. This is the path of the interstellar comet. It is a visitor that was never truly ours. Imagine this visitor rising from the frozen, silent depths of the void. It has travelled for millions of years in total darkness, a cold and dirty snowball of ice and ancient dust. It has no name, no history, and no master. Slowly it falls toward our sun. As it approaches, it begins to wake up. The heat of the star touches its skin, and the ice begins to sublime, turning directly from solid to gas. A magnificent tail unfolds behind it, a banner of white dust and blue gas stretching for millions of miles. For a few weeks or months, it hangs in our evening sky. It seems motionless to the human eye, a ghost among the fixed stars. We look up at it and feel a connection. We name it. We calculate its position. We admire its beauty. It feels like it belongs to us, but this is an illusion of perspective. The comet is not stopping. It is falling past the sun with terrifying speed. As it reaches its closest point to the star, it is moving faster than anything we can easily comprehend, hundreds of thousands of miles per hour. This is the turning point. In an elliptical orbit, the object would swing around and begin the slow climb, back to where it started, destined to come back in 70 years or 1,000 years. But this comet is on a hyperbolic trajectory. It possesses too much energy. It swings around the sun, but the turn is not sharp enough to close the loop. It is a slingshot maneuver. The sun tries to grab it to slow it down to capture it, but the comet screams past, stealing a little bit of the sun's energy as it goes, adding to its own speed. It creates a wide open arch. It changes direction, but it does not change its intent. Its intent is to leave. Once it passes the sun, the physics of departure take over. The sun pulls from behind, trying to drag the comet back, but the comet is too strong. It climbs out of the gravity well. Its speed decreases, but it never reaches zero. Even at an infinite distance, it will still be moving. It has what scientists call hyperbolic excess velocity. It is the speed of no return. This is where the science ends and the emotion begins. The hyperbola is the geometric definition of a one-time encounter. It mirrors the most painful of human experiences, the brief intersection of two lives that are destined for different destinations. We often want to believe that people like planets are in orbit around us. We want to believe that if someone leaves, they will eventually circle back. But sometimes a person is a comet. They enter our lives with a burning intensity. They brighten our sky. They change our atmosphere, teaching us lessons about wonder or fear or beauty. They may get close enough to warm their hands by our fire to let their guard down to show us their true colours, but their velocity is too high. Their internal geometry is set on an open curve. As the comet fades, it does not head back to the familiar constellations of the zodiac. In this specific instance, let us imagine it drifting south, crossing the celestial equator, heading down toward the constellation Columba. Columba represents the dove, the bird released by Noah to find land, the symbol of peace and deliverance. There is a tragic irony in this direction. The dove is supposed to return with an olive branch, a sign of life. But our comet heads toward the dove only to pass through it using the stars of that constellation as a gateway into the true dark. We watch it fade. First, it requires a telescope to see, then it is just a faint smudge on a digital sensor. Finally, it is nothing but a set of coordinates on a computer screen, a mathematical ghost moving further away with every ticking second. It vanishes into the shadow of Columba, the darkness swallows it. The lesson the comet teaches is one of scale and brevity. The time it spent near us, those few glorious weeks, is nothing compared to the timeline of the universe. It travelled for eons to reach us, and it will travel for eons after it leaves us. Our encounter was a microscopic spark in a timeline of infinite night. It teaches us that not every story has a sequel. Some chapters are written to be read only once. The comet does not look back. It does not regret the warmth it leaves behind, nor does it fear the cold ahead. It simply follows the laws of its own motion. It accepts the geometry of departure. Eventually, the sun becomes just another bright star in its sky, indistinguishable from Sirius or Proxima Centauri. Then it becomes a faint dot. Then it is lost entirely in the glare of the Milky Way. The comet returns to the deep freeze, sealing its secrets back into the ice, silent once more. It enters the interstellar void, the space between the stars where the concept of here and there loses its meaning. It will never see our sun again. It will never see Earth again. The hyperbola is an open road that leads everywhere except home. We have arrived at the final pages of our journey together. It has been a long and beautiful voyage through space and time. Think back to where we started. We began not with things, but with nothingness, followed by the greatest spark in history. We travelled through the birth of the very first atoms. We watched as gravity, that invisible sculptor, pulled dust and gas together to ignite the first stars, lighting up the dark theatre of the cosmos. Throughout this series, we have witnessed the violence and the beauty of the universe. We saw how stars live and how they die. We learned that the death of a star is not a tragedy, but a gift. When massive stars explode, they scatter the seeds of life, carbon, oxygen, iron across the galaxy. It is a profound truth to carry with you. The atoms in your right hand and the atoms in your left hand likely came from different stars that perished long ago. You're not just in the universe, you're of the universe. You're made of stardust, organised into a conscious being that can look up and wonder. We also drifted past the silent giants, the black holes. We learned that they are not just monsters consuming everything, but they are often the anchors that hold galaxies together. Without them, the beautiful spiral of our own Milky Way might not exist. We travelled through the calm neighbourhoods of our solar system, past the storms of Jupiter and the icy rings of Saturn, finally arriving back at our own small blue world. Now that we see the full picture, we are left with a feeling that is rare and precious. It is a feeling of humility. When we look at the sheer scale of what is out there, our daily worries begin to shrink. The universe is roughly 13.8 billion years old. In comparison, a human life is less than a blink of an eye. The observable universe spans billions of light years. Earth is smaller than a grain of sand on a vast beach. For some, this smallness might feel frightening, but if you look deeper, it is actually liberating. It takes the weight off your shoulders. The universe is too big for you to carry the burden of everything alone. It reminds us that we are part of a grand interconnected web. We are travellers on a pale blue dot floating in a sunbeam protected by the vastness of space. This perspective brings a deep, settling peace. It tells us that we are exactly where we are meant to be. However, as we close this chapter, we must remember that our book of knowledge is far from complete. We have only scratched the surface. Scientists tell us that everything we can see, every star, every planet, every gas cloud, and every person makes up only about 5% of the universe. The rest is a mystery. It is filled with dark matter and dark energy, invisible forces that we are only just beginning to understand. This is not a failure of knowledge, it is an invitation. The horizon is always expanding. Just when we think we have reached the edge, we realize there is more beyond. There are questions waiting for answers. There are discoveries waiting for future dreamers. The universe keeps its secrets well, revealing them one by one like a never-ending story. But for tonight, we do not need to solve these mysteries. We do not need to calculate the distance to the next galaxy or understand the physics of time. Tonight it is enough simply to exist. It is enough to witness. So I invite you now to let go of the facts and figures. Let the science fade into the background. Let us shift from learning to feeling. It is time to rest. Find a comfortable position. Let your shoulders drop away from your ears. Unclench your jaw. Let your hands rest gently. Take a deep, slow breath in, filling your lungs with calm air. And now breathe out slowly, letting go of the day. Let go of the noise, the screens, and the lists of things to do. Imagine in your mind's eye that you are lifting off from the ground. You are weightless. You are floating upward, light as a feather rising above your roof above the clouds. The sounds of the earth below you fade into silence. There is no wind here, only a perfect stillness. You are safe. You are comfortable. You are drifting into the velvet embrace of the night. Look around you. The sky is no longer a flat ceiling. It is a deep, endless ocean of darkness. But it is not empty. It is dusted with diamonds. Millions of stars are glowing with a steady, gentle light. Some are bright white, piercing the darkness. Others are soft yellow like distant candle flames. Some are cool blue and others are a faint, sleepy red. They are not twinkling. They are steady and calm, watching over you. You're floating towards the center of the Milky Way. Imagine the galaxy as a great river of light flowing through the dark. You are drifting on this river. It is a stream of starlight glowing with a milky pearlescent white. It is vast and silent. There is no rush here. The galaxy turns slowly, taking hundreds of millions of years to complete one rotation. In this place, time slows down. There is no yesterday and there is no tomorrow. There is only the eternal now. Feel the spaciousness around you. There are no walls to confine you. There is only the expanded horizon stretching out to infinity. This vastness is soft and comforting. It wraps around you like a heavy, warm blanket. The silence of space is the deepest silence you have ever known. It is a silence that quiets the mind and soothes the soul. As you drift deeper into this river of stars, visualize the beautiful clouds of cosmic dust, the nebulae. They are like mountains of colourful mist glowing in shades of violet, deep indigo and rose pink. They are the nurseries where new stars are sleeping, waiting to be born. You pass by them slowly, feeling a sense of ancient wonder. Everything here moves with a slow, majestic rhythm. You are part of this rhythm. Your breath matches the slow pulse of the universe. With every inhale, you draw in the peace of the stars. With every exhale, you release any remaining tension into the void where it simply dissolves away. You're a child of the cosmos, cradled in the arms of gravity, floating in the great expanse. The horizon continues to expand further and further, but your eyes are becoming heavy. The lights of the stars are becoming soft blurs like streetlights seen through a rainy window. The beauty of the universe is still there, but it is fading into a gentle background. You are safe in this vastness. The stars will keep burning while you sleep. The planets will keep turning while you rest. You do not need to hold it all together. The universe has been doing this for billions of years and it will continue to do so. Let yourself sink deeper into your bed, feeling the connection between your body and the earth, and the connection between the earth and the stars. You are grounded, yet you are infinite. The journey is done for now. The book is closed. The horizon is wide and open. The stars are your nightlight and the silence is your lullaby. Drift along the Milky Way. Let the current of the cosmos carry you into a deep, dreamless sleep. Good night, traveller.